Okay, so when it comes to when we're comparing volume and one of the dimensions, okay, it's gonna result in a cubic function. Okay, and one thing I need you to know about a cubic function when it comes to volume in particular, in this case, make this sketch, please. I don't want to answer the entire question if I can just get you to understand this. Based on this here, this is our volume, which is in cubic feet. And this is, we're comparing the height of this box that we've created, and that is just in feet. Okay. It turns out that if you create a box, okay, let's try to draw a box as best as we can. If you were to change the height of this box that you are creating, you're designing a box and you have the choice to make the box deeper, right, or shallower. If you were to graph it at a height of 0, you have no volume, right? If this were to be exactly 0, you don't have a box, you have a piece of paper or a piece of cardboard. But as you start to increase the height, the volume of that box would also increase. But something interesting happens. You reach the maximum. Like there's a point that you can adjust your height, that you reach the maximum capacity for this box. And after that, it starts decreasing. And this is a cubic function, folks. So what you're going to see is it's going to touch the x-axis right there. And that's where we stop. We no longer consider anything past it. Does it look like a parabola? It does. But on your calculator, it's going to continue. What I need you to know is if you ever get one of these and they ask you, right, for the what's the maximum volume possible, you're going to focus in on this. This part right here, this part right here is non-permissible. Okay? Because think about it, at this point your volume actually goes negative. You can't have a negative volume box, right? It's not possible. And when you come out here, this height is going to be longer than is actually possible based on the options you have. Okay? So you're only going to focus on this. Okay? Focus on this. Okay? This part right here is what you're going to focus on. So this is going to give you the max volume right here. The max volume is found at that peak here, which is kind of like the vertex, the local max. So when it comes to cubic functions involving volume, please do not consider anything past it, right? So this is going to be your scenario here. I actually want you to try this. Just type this in real quick. We're not going to graph it in detail. I've never seen a question where you have to graph it. Type this into Y1, please. Does this look like a cubic function to you? Is there a power of 3 there? There is none. But can you imagine what would happen if at some point I have to multiply this h by that h, that's already h squared, and then that will multiply another h, that's h cubed, right? So this is going to be a cubic. That is your first hint. If you miss that hint, what is the volume measured in? Cubic feet, right? So that's your second hint that this is a cubic function. So type that in. So I go x brackets 4 minus 2x brackets 5 minus 2x brackets. I put it in exactly the way it's shown. Let's try to graph this thing. You see that? That's what I see. I'm going to try zoom standard. So zoom standard shows me this, and again, you're only going to focus on this part right here. We don't care about it going under the curve, under the x-axis anymore. This is to be omitted, so we're just focusing on here. Let's focus in on this one here, because this is the one I really want you to know. What's the maximum volume of the box that can be created? Maximum is going to be found by going second trace max, and let's go find it. Enter, enter, enter. There it is. 0.74, 6.56 is that point exactly. What does this represent? This is the height of the box, and this is the volume of the box. We were told that right from the beginning. H is the height in feet, which is my x variable. V is the y variable. So the maximum volume that is possible under these circumstances would be 6.56 cubic feet. I'm going to leave it at that. I just wanted to make sure you have seen this.